What's good, math family? In today's video, we're going to look at 3 methods on how to simplify fractions that have radicals. Our first method is just going to be to rationalize the denominator. So we already know we can have a radical in the bottom of the fraction. So we're going to multiply by that same radical to get rid of it. So we have radical 2 over radical 4. We know this is a perfect square. Once we simplify, we'll have radical 2 over just 2. Now we go to the second example, right? And understand, math family, I'm going to be switching between the first 2 methods. So when we go to this method, right? The second problem, we do the same thing. Multiply by radical 3, we get radical 36 over 3. Once we simplify, we get 6 over 3, which is just equal to 2. But there's a different rule or method we could use called the quotient of radicals. And basically, what we could do is combine our radicals. So let's say, you know what? Let's say we had this, right? And we switched it to the square root of 12 over 3. And now if we simplify this, we get the square root of 4, which is just equal to 2. So this is another method that we're going to use. And like I said, we're going to switch between these 2 methods in our next examples. Continuing this video, let's say for this first problem, we just went with the first method of rationalizing. So we multiply by the radical that's in the denominator, right? And just understand that we're following also the properties of exponents. So when we multiply, we're going to have 36 x to the 8th all over what? What's just left under the radical? 2x to the 3rd. So now we simplify the top. We get 6x to the 4th all over 2x to the 3rd. And now once we simplify, our final answer is just going to be 3x. But if we use that second method, right, and we go back and we could just combine those radicals, we could get the same answer with less steps. Oops, wrong number. All right, so we divide. And oh, math family, just remember, for us to do this, the radicals have to have the same root. If they don't have the same root, this rule cannot be used. So now we simplify this. We have 9x squared. Then once we break this radical down, we're going to get the same exact answer of 3x. Now we go to the next example. And we can break this radical down just to x squared radical 2, but I'm going to keep it the same. So we multiply, right, by the denominator. So now we have 100 x to the 10th, right? Radical 100 x to the 10th, all over 2x to the 4th. We know this is a perfect square. We simplify this to 10x to the 5th, all over 2x to the 4th. Once we simplify one more time, we are going to get 5x as a final answer. Now, like I said, math family, let's imagine if we use that quotient rule of radicals. So if we combine that all under one radical, right, because it has the same root, this is what we'll get after we divide. So now I divide 50 by 2 to get 25. X to the 6 divided by x to the 4th gives me x squared. And now once I look at this final radical and simplify, we're going to have 5x as a final answer. So these are the first 2 methods that we could use to simplify fractions that have radicals. Now we're going to go into the last part of this video. Last part of this video, math family. So when we're simplifying fractions that have radicals and they have binomial expressions, right, in the denominator, we have to use the conjugate and understand the difference of squares. So remember that this is the difference of squares, right? A squared minus b squared. We know we have a plus b multiplied by a minus b. Middle terms cancel out. So why is this important? This is going to help you speed up your problem solving process. So if this was the bottom of the fraction, right? 6 minus radical 12. Its conjugate is the same thing with the opposite sign. And we're talking about subtraction and addition. So this would be plus. So let's say we use the box method, right? And understand, math family, when we do this, or when you multiply the same radical with itself, it's just the number without the radical. All right. So we go through, we have 36, negative 6 radical 12, positive 6 radical 12, and this is negative 100, well, the opposite of the square root of 144, which is just 12, right? The number without the radical. So these two cancel. We're left with 36 minus 12, and we'd have an answer of 24. Once you understand that principle, this becomes 10 times easier. So what do I mean? Let's erase all of this. So when we go to this problem, boom, right? Fits our conjugate, right? So we have radical 5 plus radical 2, that's the conjugate. Do the same thing at top. So let's just focus on the top. So once we multiply, we're going to get 3 radical 10 plus, oh, not 2, plus 6, right? Because radical 2, that's 4. Square root is 2 times 3 is 6. All over, you know what? Let's not even do 25. 5 minus 2, because it's just a number without the radical. So we simplify. We have 3 radical 10 plus 6 all over 3. Now, luckily for us, you guys already see all 3 of these are divisible by 3. So once I simplify, my final answer should be radical 10 plus 2 as a final answer. And now we're going to look at the very last problem of this video. In the last problem of this video, math family, same exact thing, right? We have a binomial with a radical in the bottom, so we have to use the conjugate. However, we can simplify these radicals to make it smaller numbers we work with. We don't have to, but it'll make it easy. So I know once I do radical 27, that's 9 times 3, which ends up being 3 radical 3. So when I rewrite this, I have 4 plus 3 radical 3 all over 2 minus, and if it's 3 radical 3, just remember we got to multiply it by that 3. So minus 9 radical 3. Now we get over into the conjugate, right? It's going to be 2 plus 9 radical 3. Do the same thing to the top. All right, so now this is what we're going to get. We're going to get 8 plus 36 radical 3 plus 6 radical 3 plus 27 times 3. All right, and this is all over 4 minus, and let's see what we get. I want to say this is 81 times 3. Yep, 81 times 3. So now if you guys are wondering about the 3's, just remember, multiply the 2 radicals to get 27. I mean, the 2 coefficients to get 27. Radical 3 and radical 3 is just the number without the radical. So I put it there. Now let's bring this to the top. And before we actually bring it to the top, let's simplify. All right, let's simplify. So 81 times 3 is going to give us 243 on the bottom. And 27 times 3 is just going to give us 81. So let's just take that into account, right? So we know we're adding 8 and 81. I mean 8 and 81 to get 89. Right? And let's switch back to black now. Then we go back and we add our radicals, right? Same number under the radical. We had 36 and 6. I believe that should be 42. So 89 plus 42, radical 3, all over 4 minus 243, which is going to be equal to negative 239. So this will be my final answer. We're not going to worry about simplifying for now. But these are the 3 methods and the most common ones that you're going to see on how to simplify fractions that have radicals. Comment down below if you enjoyed this video and if you want to see the quotient rule and more problems on how to combine those radicals and divide. Thank you guys so much for joining us today on Algebra 1 with Mr. Peters. Smash the like button for us, subscribe to the channel, and join us on our next video.